This conference will now be recorded.
Good morning, everyone. Are you able to hear my voice? Can anyone confirm? And also able to see my screen?
Yes, yes.
Oh, thank you. So today we'll start learning about AWS load balance. So we'll learn what is load balancing in AWS. So where we can find that option, where we can find that service, and what is it, we'll learn today. So it's available on the same. When we create instances here, when you come down, we have option called load balancing. So here, if you see, observe carefully, we have two options: load balancers and target groups. Today we'll do using this we can create load balancers. But before that, what is load balancer? We try to understand. Actually, in real time, suppose when you want to access Amazon.in, for example, Amazon.in website you want to access, right? So you use your browser here. From your browser, as a customer, you will try to access it through the browser. So there will be thousands of people every hour, every 5 minutes, thousands of people try to connect to our Amazon application. But our Amazon application will be running in multiple servers, will be available in running in multiple servers. So one thing you should understand, a application, Amazon application or any application, if you take for example, or any application will be running in a server, right? But the one server cannot serve hundreds of customers, right? If you take an example of a restaurant or any hotel, when you go to a hotel, then no, if one server cannot serve all the customers, right? Definitely there should be multiple servers will be available in that hotel, will serve the food for customers. So server should be more, right? If public are, if more demand in the hotel, then the hotel management will do what? They will increase the servers, so that customers will not feel any delay in their service, in getting their service. Similarly, whenever you are accessing any website, if in that case the website Amazon.in, in our scenario, is more demandable website, mostly a lot of people accessing it. So that is the reason Amazon company, what they do, okay, daily, uh, normally every day around 50,000 people, customers are trying to connect our server, are trying to, are connecting to our application, our website. So once Amazon, this application, end of the day, website is nothing but a application, right? It's an application written in one of the languages chosen, and they developed it. And this application they deployed in one server, and this one server cannot serve all the 50,000 customers every day. That is the reason what they do, they will assume, they deploy the same application in 1,000 servers, contains Amazon application running, okay? Or in different way, in 1,000 servers Amazon application is running, right? So now they will check, okay, 1,000 servers now comfortably serving 50,000 customers, no problem. Tomorrow, suddenly there is an increase, the 50,000 to, if it went to 1 lakh on the, for example, Republic Day, at the time the normal everyday connect 50,000 people increase to some 80,000 or 1 lakh every day till that offer expires. Daily the company seeing that more customers are trying to access a application. It increased from 50 to 80,000 or 1 lakh. Then they what they have to do, they have to temporarily increase the servers from 1000 to some 1500 or 1600. So that thing we will see in another topic called, what is that, auto scaling. We have another service called auto scaling, right? If you come down, we have auto scaling here. In this we will see how we can use auto scaling, but right now we are not discussing about auto scaling, but we will keep this aside for today. So 1000 servers are there now, are running in 1000 servers, that is fine. Now we'll discuss only about 1000 servers. These 1000 servers, if they are running in the cloud, 1000 servers will be running in different regions and availability zones. So I've taken 1000, but in reality there could be more than that. The count could be more than that. But as of now, try to understand 1000 servers are there. They are running in different regions because customers are in India. They can be from anywhere in India. That is the reason the application is should be running in Mumbai region, Delhi region, many other regions, Bangalore region, right? That way the application will be running in different regions. And also in each region there will be multiple zones, and each zone there will be some servers running in one of the zone, another service running in the another zone, right? Like that it will be there. Now today, to explain you what is load balancer, I will take only one region example, and in that one region also I will take example of one availability zone. So whatever I am discussing now will be applicable to all the regions and all the availability zones. But today, to explain load balancer, we'll select one of the region, Mumbai region, and I will discuss. I will take only one availability zone. So by understanding, if you understand that, then it applies to multiple regions and multiple zones. Okay, let's see. Now here there are multiple servers. Now assume, let's take one data center or one availability zone in Mumbai region. Okay, it's in Mumbai region. Okay, and availability zone is 1A. For example, we are in availability zone 1A. Now in this 1A there are some 10 servers are running. In these 10 servers, our application is, what is our application? Amazon application is running, right? And this now this is our application, right? In this example, because of lack of space, I'm taking only 4 servers now. Now these 4 servers, in these 4 servers our application is running, app our app is running here. And this app actually is running in one server. This is one EC2 instance, one EC2 instance. This one is EC2, this is another EC2. Okay, like that. So these are different EC2 instances. There will be another EC2 instance. This could be another EC2 instance, and in this there will be database running. As you know, application will not have data, right? It has to connect to our database DB. This DB, this another machine, it having DB running in this. Inside DB will be running, and this another instance. So normally you should understand that a application definitely has to depend on database. I'm sorry, the application has to be depend on the database always. Explanation takes time, practicals is very easy. If you understand this, practicals is very easy. Now this app will communicate with the DB whenever it requires, right? Now, assume we have 4 servers running here now. 4 servers are there, and each server is will communicate with the DB. So suppose this guy want to view mobile application, then he will click the mobile application. Immediately the browser through internet, it will connect it to our server. But actually in between many things are happening. One moment, please. Am I recording? Yes, it's recording. In between, when this guy clicks on mobile application, one model, that model details he want to view, then the request will come to this one of the server. So assume the request came to this server, then this application will connect it to the DB, and it will provide the details, mobile details to the DB. And if a DB will do what? The DB can be, it also a software. The software could be SQL Server or Oracle, or it could be PostgreSQL, or there are many different types of DB softwares. Okay, all DB software do only one job. They are very efficient of searching the required information very fast. They use different algorithms inside the database. They use different algorithms to fetch the required information very fast. In microseconds, they will search the data. That is the reason application gives the mobile information where this guy wants to view, that this DB will immediately search the details about that model and gives the details back to our application. Then our application neatly it will pack that information in a HTML format. HTML is hypertext markup language where the browser understands. The browser understands HTML only. For example, if you open this view, if I right click here somewhere, if you click somewhere here, if you go to view page source, for example, you see it's coming with HTML, right? Everything is HTML. Everything is HTML. Okay, so internally it's using the body div, everything is HTML. So our Amazon application, whenever this guy wants a mobile model, the model information, Amazon application will ask to DB gives the application, and this application immediately packs that information in a HTML format. So this will pack inside HTML file like this, and this file will be given to back to the browser where this person is using. The browser, once it receives the HTML page which contains the model information, that information will be displayed on the browser, so that the end user we can see the information in a proper way. So that way these applications serve them. That is fine. Up to here, no problem. But thing is that actually this guy cannot communicate immediately. Suppose he can, many people trying to connect to the servers, many people, like thousands of people trying to connect to our servers. Now this particular application, which is server which having our application, is already serving to this guy, and suddenly this guy also wants some information. Because it's already busy now, then this guy cannot connect to it immediately. If he connects to this immediately, then this guy may feel he get delayed actually. Why? Because this person is already serving. But this guy, the another application server which is free now, it is actually free, but the request went to the same server, then it's problem, right? So this guy feel delayed. Same happens in the hotel also, right? There are multiple servers available, and if same person is called by the customers, then if 2 3 customers using the same server in the hotel, then they will feel the delay. But if another person joins, another server joins, and he takes the order, then the customers will not feel any delay, right? But the who should know in the hotel, who should know that other server is free? The one head person should be over there, who should be observing all these things, and he should observe that okay, the server A was serving a customer B, and now another customer want to again asking the same customer A, sorry, again asking the same customer server A. Then the head person, who is head of this all the servers, you should immediately understand that okay, this server A is getting busy. Then what you should do, you should see which server is free in the hotel. Okay, this server, another server with B name is free now. Immediately you will tell him, go and serve that customer, because server is A is busy, he is serving to another customer. Take his order and help him out to finish his order. That way one head person will be there. Otherwise, if such a head person is not there, then the hotel management will not be good, and customers will not come back to that hotel again. Similarly, if the web servers are not responding quickly, then these guys will not go back to amazon.in. Next time they will go to Flipkart, because in Flipkart, assume the management is very good, they are serving very fast, the requests are providing very fast. That way there is a good chance of diverting of the customers from this application to another website. That is the reason here what happens is the companies use a concept called load balancer. They use the load balancer concept they use. So it's like a head in the hotel. This load balancer, what it will do is a load balancer. Now the name itself saying, no, load balancing. Okay, it's a load balancer. Now onwards, whenever a request comes, actually in real time the request goes to the load balancer first. Then load balancer do what? Okay, which server is busy, which is free, it will check. If this server is busy, then this server is free, then the request will be given to this server. The request will be sent back to given to this server. Now this guy want to connect to you want some information about some refrigerator. He also browsing the same website. The request again goes to our load balancer first, and this time load balancer found that okay, this instance is busy, this server is busy now, but this server is free. Then the request will be given to the server which is free. Then the request will be passed on to that server. So in short, what I'm trying to say is that there will be a load balancer in between. Every request actually will not directly connects us to the server. That you should understand. Definitely, for any application in industry, in IT industry, for any application there is a load balancer will available. So always your request goes to the load balancer first. The load balancer decides, it is job of the load balancer, it decides which server is free, and basing on that the request will be assigned to that server. Hope you understanding this. If you're not understanding, let me know, I will clarify. And at the same time I want to add one more topic. If you understood this point, then I want to add one more point here. Please understand that normally in real time, for every application we don't have one dedicated DB server. Actually this DB server normally is used by multiple EC2 instances which having our application. So if there are 10 applications, the 10 applications might be using the same DB instance, might be using the same DB instance. Okay, so here in this scenario, in this scenario, here I'm in this picture I'm giving showing that each instance having a dedicated DB, but that is not correct. Okay, as I tried to explain you that I just added here, but actually you can have multiple servers, and multiple servers are trying to access. Suppose there are 10 EC2 instances which having our Amazon application running in 10 instances. Then for those 10 there could be only 2 DB instances running for them. Only 2 are enough to serve those 10 services. For 10 servers which having application will not have 10 DB servers. You should understand that. You should understand that 10 servers in which application is running will share 2 or 3 servers in which database is running. Okay, so 10 servers in which application is running will share 2 or 3 servers in which database is running. That you should understand. And here we have two types of load balancers are there. We have two types of load balancers are there. One is internet facing. Internet facing. Internet facing means the one which we just discussed. this load balancer is facing to the internet. That means all requests is coming from the internet only, right? That is the reason we say it as internet facing load balancer. We have another internal internal facing also, we can say another one is called internal facing. That means why we are saying internal facing, because in this picture I told you the same picture. If you take one moment please. If you take the same instance, same server, same data center now. So it's the same data center now, right? And this is our Mumbai region, for example, AZ1A, the one which you just now discussed. Okay, let's try to copy, whether I can copy this or not. Not required. Let's see. Nice. So, for example, take this 4, and this 4 will be using 1 dB, 1 dB instance. This another EC2, this another EC2 instance, right? These also 4 are different instances. All of them same application is running. This all want, suppose this guy from internet, some guy want some model, some details about a model, some of the model information. The request, as you know, we already I told you that we have a load balancer in between, right? So the request comes from the browser to the load balancer, and the request will go to one of the instance. For example, take this one. Okay, but internally there will be another load balancer also. Internally we have another load balancer. This is another load balancer. This is called internal load balancer. Okay, internal load balancer. So now there could be, assume, this paintbrush, kids can play very well, but I am very poor in this. What happened now? How to draw now? Now we have two DBs here. Try to understand. We have two DBs here. Database 1 and this is database 2. Both having same data. Both having same data. It's just replicas. It's just replicas. Both having same data. Now this guy want to view some data and request this load balancer chosen this one. Choose this application, and this application want that information to be fetched from the database. So this database may be already serving this server. This database may be already serving this server. Now when this server want to get the information from the database, the request first goes to the internal database, and internal database decides which database is free now. If it is already serving this in this instance, which this server, then the request will be sent back to this server. Similarly, if another request comes to this application, and if both are busy, then a delay can be expected, but that delay also will be removed by the architect people. They will understand, okay, some delay is happening to the customers, let's increase few more databases servers instances. That way they will increase the database, or they will use auto scaling concept. When they use auto scaling concept on databases, then automatically cloud understands, okay, here two servers are busy and this load balancer is unable to serve the customer, then auto scaling in service will immediately create one more instance with the same database. How to do that we will see when we learning auto scaling, but as of now try to understand, we have auto scaling concept which will take care about if servers are not sufficient, enough servers are not sufficient, it will create them. But end of the day, what we learned till now, we have two load balancers. We have two load balancers. One is external or internet facing, and another is internal. Let me know if you have any doubt. We have internal load balancer and we have internet facing load balancer. Two different load balancers we have. I will wait for few seconds. If you have any questions, please ask. So that now we are jumping into practicals. So before doing practicals, I want to make sure you are in sync with me. Okay, you are surprising me. I am teaching so well, or don't understand. Okay, nice, nice. Okay, then let's go to practicals now. Okay, and before we go to practicals, we have a concept we should understand: target groups. So now, what is target groups? So when we trying to create when we want to use a load balancer service inside Amazon Cloud, first of all, to the load balancer, we have to inform to load balancer saying that I have 4 servers, and these are the 4 servers I have, and the list details of these 4 servers I have to give to load balancer. Then load balancer will take care of them. And also load balancer, to load balancer we also inform various things, like how to communicate with them, how to communicate, how to know whether they are busy or not, what are the messages it has to send to them, so that they will say whether they are busy or not. Because end of the day, load balancer has to talk them. If they inform that they are busy, it will ask to them whether are you busy or free. If they're free, it will say yes, I am free. Then the load balancer will transfer that information data request to that server. If the server is busy, then it will say yes, I am busy. Then the load balancer will go to another server. Like that, each load balancer and each server will communicate each other. How they communicate, everything we have to mention inside our target group. So in the target group, what we have to select, we have to provide the instance details. Target group. Okay, here add all the servers to be handled by the load balancer. Okay, so here add all the servers to be handled by the load balancer. So first of all, where are the servers? We don't have any servers. So what I will do? Let's create 3 servers now. Okay, I want to create 3 servers now. Okay, let's take Ubuntu. Okay, now I want HTTP as well. Okay, one moment please. Load, one moment please. Yep. And one thing I want to add up here, because we are this, I told you that load balancer will connect to any of the server, right? Any of the server, right? But to make you differentiate to which server is connecting, I will change the color of background color of each server, so that by seeing the color, you will understand that our load balancer is really connecting to different server. That way, we'll understand that okay, we are connecting to different servers. Just for the sake of understanding that concept, what I want to do, I want to change the background color of each server. How to do that? In the HTML file, we have to do that. Okay, let's install. Let's get 3 servers. Okay, and because I want to connect to that instances, I want HTTP to be enabled. I'm enabling that as well. How many servers I want? For this example, I want to take 3 servers. Then launch instance. So these are the 3 servers which we are creating now. So out of these 4, I am taking 3 now. 3 servers I'm creating now. So few things I will do little fast because I believe you already know those, already we learned them and you practice them. So this I will make as server 1. This server 3. Oh yes, 3 servers now. Let's connect immediately these 3 servers. Let's select first server now. And control V will not work. Right click and paste here. Okay. To the screen. So same things what we did before. Sudo I want to become a root user, and then I want to change this name. I want to change this name. So what is the command we have to use for that? If you don't know, the command is simple: host name, and name I want to give it server 1, and then you have to run a command called execute bash. Now if you see here, we got a server name here. My root user, I have converted to root user, and host name I have changed it to server name server 1, and execute bash. So the bash contains these details. So bash will once executed, the name will change it to server 1. In real time, we do this like this only because we can't, by seeing the IP address we cannot differentiate which server we are working on. That is the reason best to give some name to it so that we can easily differentiate. Clear the screen now. Now let's connect to the other server. Click on instances. Same, let's become a root user and change the name server 2. Okay, clear the screen. Right, we have 3 servers ready now. So these are 3 servers. Now what we have to do, these servers, in these 3 servers, let me install Apache. So what you have to do, apt install Apache 2. I forgot to update it, right? Apt update F1Y. This should be done initially, okay? Otherwise, some unknown issues will can happen. So better always, it's good practice to update a new server always. The first server I missed it. Let's see if how it behaves. Now it's done now. Now to the HTML, I want to add some text. So what I will do, we have a website called W3 Schools. Just type W3 Schools, click on it. W3 Schools, remember, is a good site. Okay, go to HTML and just on the same page, come down here, try it yourself. Some option is there. you see, if I want to change some text here, I want to change some text here. This is a text I want to use now in our server as well. What I will do in this here, I will say this is server 1. I will say like this, and this server 1, and page title I will say something green or orange. Okay, why I'm saying orange, I want to give this color of this screen as orange. So what I have to do, if you know a little bit of HTML, you can understand this. Here I want to change the background color to orange. So to learn load balancer, this is not required to understand. Just for the sake of look and feel, I'm changing it. If I run here, this is the content I will get. This is the content I will get. So this I will copy. Okay. Now in the first server, let's go to the HTML folder. Where it is in the var folder, www folder, HTML folder, it will be there. Okay. ls you say here index file is there. Okay. Open it. Vi index file. Open it. This all I want to delete it. So command is how to delete all the content. It is ggdg. This is the command we have to give. So everything will deleted. ggdg. Everything is deleted. It's VI editor. It's all related to commands. So one by one you practice, you will remember. So insert. Go to insert mode now. I'm in insert mode now, and now I want to paste the content. I have pasted it. Escape. Okay, it's saved. In our previous session we saw this, right? How to save, use this later. WQ. Enter. It is saved now. Now let's go to our instances. The first instance is ready now. The first instance is ready now. Select it. Okay. Now go to our security. I'm sorry, what is the details? Click on details and select your public IP. Now let's try to use it. Enter. See, this is first server ready. First server is ready. Now similarly the same thing I want to do with the server 2. Hope you understanding this server 2 now. This time I will say some green color. Here is simply green. Check it. It's working fine. Copy this content and let's go to our second server. So cd var. What happened? Okay, it's I think I have not installed in Apache here. Let's do the same with other one, third server as well. Now it is ready. Go to W folder and HTML and VA index, open it, right? GGD capital G remote, insert mode and paste the content. This color is done. Similarly, here this is a, what is this? VA GD is also ready. Okay, GGD. Here I'm pasting it, but here some mistakes are there. I to be removed, and here I want to change this to some other color, cyan or something. Okay, this is code. You can think it as this is Amazon code. You can think it as Amazon code, but I'm just giving the background color different. Yeah, right? So 3 servers running some Amazon code. Now we have another server. Let's test the second server. Enter. It is green, and you see the tab name is green now. Title also coming green. Let's select the last one. Okay, this server 3, right? So server 3 we forgot to change it, right? So just come down, go to insert mode, delete it and make it 3, escape, call exclamation WQ. Done. It is done now. Now if we refresh it again, Why it's taking so much time? Okay, let's change it now. We have three servers ready, but thing is that as per the diagram, these servers, this as a customer, you should not access them directly, right? You should not access them directly. But here, if you try, if when we are trying here, we are accessing them directly. This should not happen. We should not access them directly. Only our load balancer should access them, but load balancer should allow these customers to access it. So load balancer, they should come through the load balancer, but these people connecting to directly to our instances. So for that, we have to do some changes in the security group. First of all, let's create a load balancer. Okay, first of all, let's create a load balancer. So here, what I have to do, go to here and click on load balancers, right? But load balancer also, we require a security group, I told you, right? So what I have to do, let's go to our security groups, create a new load balancer, new security group. Here, so all requests coming from whom? From where? Internet. All requests coming from the internet, right? All requests coming from internet, right? So I should say in the security group, the request is coming from HTTP. All requests coming from HTTP, and who will access this load balancer? All people, everyone can access it anywhere. So this load balancer is accessible by, it is internet facing, right? So anybody can access, right? That is the reason the source will can be anywhere. So through internet, anybody can access it. Okay, this is the rule I want to give to our, what I did in where outbound rule. This is a mistake, right? I did in outbound rule. This is a mistake. So what I do, I will cancel it. I'll cancel it, and again I'll click here, and here by default it's showing outbound rule. That is the reason I mistaken there. So just say load balancer, okay, or you say Amazon load balancer, and then add your security group. And here you can copy the same thing here and come over here, add a new rule. Here it will be your HTTP, right? And your custom anywhere. Okay, the rule is now ready. So now come down and say create a security group. And next thing is that, next step what I will do, I'll come down and I will click on not load balancer, I'll click on target groups now. Click on target groups. Okay, now we'll see what is target group, how it looks. Close this. Let's click on create target group. Click on it. Now it's saying in this group, which what are you want to add? I want to add instances. I want to add our three instances. So this is what I told you. So to our load balancer, we have to tell which are the servers it is going to manage. What are the server details? That details I have to provide to load balancer. So these details I will provide inside the target group. In this target group, I will mention about our three instances which we have created just now. These three need to be added into our target group. Let's see how we can add them. Come down, and here you see you have health checks. We have health checks here. So we want, in our target group, we want to add instances, and come down. What is the target group name? So Amazon, okay, EC2, okay, or Amazon servers. I will say PG. It indicates target group. It indicates target group. Okay, and how this will be connected through HTTP. How these target groups are connected to our instances? Through HTTP. That means our load balancer use HTTP connection request. It gives a HTTP request to our instances. That is the reason by default it will show as HTTP request. Okay, and what type of IP address we are going to use? IPv4, and we have IPv6 as well. IPv6 we will find on our mobiles. On mobiles we have IPv6, but we will use IPv4 only mostly. If they exhaust, then people may go for IPv6 as well, no problem, right? And VPC we have not learned as of now, but when we learn, we come to understand what is VPC, virtual private cloud. It's like a data center on the cloud. It's a logical data center on the cloud, like that. Okay, in real time, without your own VPC, we will not work. But as of now, we are using a VPC, which is a default VPC. Whenever you create an account in Amazon cloud, a VPC will be created. So till now, whatever instances we are creating, whatever S3 buckets we are creating, everything comes under this default VPC only. but in real time we won't use default VPC. We will create our own VPC. What is that? We'll discuss when the topic comes. Now health checks. I told you, no, here in this picture, this load balancer will check whether you are you busy. It will ask. If it is busy, it will respond, yes, I am busy. So how that will be checked? Here you have to mention it. Click on advanced health check settings. You come here. It's saying healthy threshold. The number of, one moment please. Here, oh yeah, fine. Here, healthy threshold, the number of consecutive health checks successes required before considering an unhealthy target healthy. That means here it is said 5. That means this rule saying that this load balancer should ask it 5 times. If it continuously 5 times it says that I am healthy, then only consider it as a healthy. Just first time it said healthy, then immediately don't give the request, transfer the request to the server. Let's wait, let's ask it for 5 times. If it 5 times it's saying I'm healthy, then only you pass the request to the server. So that is the meaning of that. So it's 5 times. You can, minimum is 2 times to 10 times. You can give 2 times or 10 times, maximum is 10 times you can ask. Similarly, unhealthy threshold. How to decide whether a server is unhealthy? The number of consecutive health checks failures required before considering a target unhealthy. Here it is mentioned as 2. That means this load balancer will ask, I have a request, can you take it? Then this says, yes, no, I'm unhealthy. If it says like that twice, then this load balancer immediately goes to another server and it again asks, are you healthy? It says, no, I'm not healthy. It says twice, then the load balancer will go to the third one. Like that, it will load balancer will search for the servers which are healthy. Timeout. The amount of time in seconds during which no response means a failed health check. The amount of time in seconds during which no response means a failed health check. So what is that? So if 5 seconds, so this guy load balancer asking H2 instance, are you healthy? But this server is not responding at all. Assume. So it will wait for how much time, seconds it has to wait for its response. It has to wait for minimum 2 seconds to 120 seconds. Here it is shown as 5 seconds. It will wait for 5 seconds. Okay. And if it is not responding in 5 seconds, then immediately load balancer will go to another server. Interval. The approximate amount of time between health checks of an individual target. 30 seconds it say. Minimum 5, maximum 300. What does it mean? That means now this guy asking, are you healthy? It says, no, I'm not healthy. Okay, it asks second time. No, again it said, no, not healthy. Then this load balancer will not immediately go to the another instance. It has to wait for 30 seconds. After that, it can try with the same instance or it can try with another one. So after uh, every time it checks healthy or unhealthy, after that it has to wait 30 seconds. And what is the codes we have to use? Here we have 200, where we have 200 to 299 codes we can use. These 200 299 codes, any code, if this how it says I'm healthy, this instance will send a code 200 or 201 or 202, whatever number we specify here. Here I'm specifying 200 by default. That means you can mention 220, 30 also. Till 299, all considered as success codes. So the instances will respond with a number 200, 200, 202 something. Then load balancer thinks that okay, you are healthy. But if it's sending a response other than 200, if it's sending 404 something different number, 501 something, then this load balancer 500 or something, then load balancer thinks that okay, it's not healthy, it's not healthy. So to get a healthy information, the instance should send 200 as a code. The HTTP codes used when checking for healthy response from a target. So 200. Here I mentioned 200. You can mention anything. So that's all about. This way, will the load balancer has to check those information. Those information I am providing in the tired groups. What we are going to provide in the tired group? We are going to provide what are the instances the load balancers to be handled, and how the load balancer to check whether they are healthy or not. These are information we have provided inside tired group. Then come down, click on next. Here register targets. We have 3 servers running. Do you want to add all of them to as a target group? Yes, I want to add all of them. Then select all of them. No, I don't want to select all of them. I want to select only these 2. You can select as well the only 2. So load balancer will maintain only these 2. The third one it will not be maintained by load balancer. But I want to maintain all the 3 servers by the load balancer. Then select all the 3. Our server 1, server 2, server 3, which we created just now, all will be displayed here. Okay, once you select, you click on include pay as pending below. You have to click on this button, include as pending below. When you click this one, that all will be added here. Click here. Now all are added here. So all are added here now, and you see carefully, just Now click on create target group. All are added now. Click on create group. Now you see carefully, 3 are added, but the status what it is showing, unused, unused, unused. The servers will be ready only if the health status shows us healthy, healthy, healthy. Only then our load balancers can serve. Only then load balancer can forward the requests to the servers. But as of now, all are saying unused. That means why it is saying unused? Because we have now we have to attach our load balancer. Sorry, our target group. This is the target group we created just now, right? This we have to attach to our load balancer. When we attach it, then load balancer start using these servers. When he starts using these servers, then the status will immediately changes to initial, and then from initial it goes to healthy. That we'll see in a step by step manner. Just I want to duplicate this window, come down, click on load balancers, click on load balancers. Now create a load balancer. Before that, let me close this window, this cross button. Create load balancer. Here we have 3 types of load balancers available: application load balancer, network load balancer, gateway load balancer, and a very old one, classical load balancer. We are it's old one, we won't use it. And this also gateway load balancers we won't use it. It normally for other purpose in real time we won't use it. But this network load balancer you can use it when only when your application gets requests in millions. For example, uh, network load balancer are capable of handling millions of requests per second. If your application getting millions of seconds requests from per second, of course in amazon.in if you use, we won't get those many requests, right? We won't get those many requests per second. Millions of requests we won't get, right? If at all we getting it, then you can use this kind of load balancer. But for our application, for our regular applications, application load balancer is more than enough. For our regular job applications it is enough. Okay, choose an application load balancer when you need a flexible feature set for your applications with https traffic operating at the request level. Application load balancers provide advanced routing and visibility features targeted at a application architecture including microservices and containers. When we learn dockers, at the time we'll come to topic of containers. So using those we can even microservices also we can use when you work with docker. So at the time we can use application load balancer as well for that also. Okay, click on create button. Now give a load balancer here. Here I'll say amazon servers something lb. I'll say lb. Now here we have 2 types: internet facing, internal facing. This is what we learned here. So we have this is internet facing, this is internal facing. So which one we have to create? I want to create load balancer which is internet facing. So I will select internet facing only. Okay, come now, address type is ip4, fine, it's a vpc. And where this load balancer should available, I want this load balancer to be available in all the 3 zones, because we don't know. As I told you, we are working on only 1A, but I want to serve this load balancer also on the 1B as well. Then 1B and 1C as well. Then you can select all the zones. So our load balancer will take care all the servers which are available on zone A, zone B, zone C. Our load balancer will take care. Okay. Now, what is security group you want to choose? Default is there. Remove it. Remove it. Set our group which we created. What is that? What is our Amazon load balancer SG? This is the one we created, right? Amazon load balancer. Select this one. Select this one, and then come down. And here is a setup. So if request coming from the internet, forward to whom? Our load balancer asking us to whom I have to forward the request. Then what is the group name? The group name you have to give here. The group name, it contains all the details, right? All the 3 server details are there inside. Select that one. That means when you say that, it is saying that whatever request coming from the internet, I will, okay, I will check these servers which are mentioned inside this target group which we just created, right? All these servers, right? These details are I'm telling to load balancer. If any request coming from the internet, you check these servers. We have 3 in this, we have 3, and how to check them whether they healthy or not, everything information provided inside this target group. Okay, you can use this that way. You can, we have to add it. Now come down. Now simply click here, create load balancer. Now successfully created load balancer now. Okay, click on here load balancers. Here our load balancer is ready, preparing, is preparing. Status is showing provisioning. it is provisioning, and our instances, if you see here, give me 5 more minutes please, 5 more we complete it. So it is showing provisioning, and let's see what is our status changing now. Let's say refresh it. Now our status changed to initial now. Our status changing to initial now. Very soon, very soon, this all should be, once it is provisioning is ready, the status is completed, then no, this all will shown as healthy. Then when it is healthy, then we can check whether load balancer is working or not. This it will take some time. You practice this weekend. Tomorrow we have class, do not forget, tomorrow we have class, same timings, no change, only one Saturday, this Saturday. I'm again pasting the schedule. Tomorrow at 9 a.m. we'll connect. This will be 2 sessions. And still there is one problem you should understand. These servers we are able to access them from the browser. That means amazon.in, assume this amazon.in, then you are trying to access them directly, but we are not, we should access it through the load balancer, right? But I am accessing directly. This should not be allowed. This should not be allowed. How we can prevent, how we can prevent that, we will see in a moment. How we can, after preventing, you cannot access like this. Then how can we access it then? So our load balancer will give you another URL. It will give you another URL. When you select this one, you come down here, a DNS name is there. This is the URL it will give. You have to use this URL. Copy this. You copy this and paste here. So our load balancer gives this user this email. This is the URL. You have to use this URL. This is provided by the load balancer. So but as a user, as a regular customer, you will type amazon.in, but internally the load, it will connect to the load balancer. Load balancer will have user URL like this internally. So internally, when you type amazon.in in a browser, actually the request goes to our DNS system, domain name system. The domain name system will know how to connect to this load balancer, how to pass the request to load balancer. Those will take internally, but we are trying to learn how a load balancer URL looks like. So it looks like this one. So you have to use this URL, not the individual IP addresses. Individual IP addresses you should not use. Okay. It is active now. It is active now. Let's see what about our instances here. Refresh it. These are also healthy now. These are healthy, and our load balancer is ready now. Okay. One thing is that we should not allow like this. We should not allow like this. Okay. Then what I have to do? So if you observe carefully, these are all the servers, right? So go to our server. This is first server, right? Go to our server and go to our security. If you see here, what is security group you having? Launch wizard 3. Even it is same for the other 3 as well. Launch wizard 3 only. If you come here, because I created 3, right? It's also launch wizard 3. I should given a good name for it, but I forgot. So you, while practicing, give a good name. Launch wizard 3. I have to change this launch wizard. Click on this link. Go here, edit inbound rules. Okay. These are inbound rules, right? So I have to change here. What I have to do is rule 2. In the rule 2, we are allowing HTTP from anybody, right? From the internet we are saying, from the internet we are allowing anybody, but we should not allow anybody. We should allow only our load balancer. We have to allow only the load balancer. So to allow only the load balancer, then what I have to do? Simply click here. Okay. And our load balancer having a security group, right? If you remember, what name we have given? Amazon load balancer SSD. This is the name we have given, load balancer. This is a security group for our load balancer. Okay. Can we see it here? So this is what load balancer. Click on security, come down. What is the name for this? Amazon load balancer. So our load balancer having this security group. This name we have to use. So how to use? Where we are using? We are using, where we changing? This is a launch wizard 3. This belongs to whom? Our 3 instances. This belongs to, this is a security group for our 3 instances. In that, what I'm doing is that this instance is having a security group. In that, I am changing security group such a way that previously it was allowing everybody, but now I will restrict it to, I will allow you only the load balancer. So how to do that? Simply come down and select our where is that, Amazon load balancer SG. You select it. One moment please, it's not reflecting, right, where it is. Okay, existing one you cannot change. Click on delete button, add again, add rule, change to HTTP, and then here custom you just click here, come down, select Amazon load balancer. Now it is selected. Now just come down, save rules. Now it is saved. Now go to orange URL. Now refresh, enter. It will rotate, but it will not show you. It will not show you. This also same. If you click it, now it is restricted. Now they cannot connect to, cannot connect us directly. Now this one, another third one. Now see, both, all three are running. You see, all are rotating, but they are not unable to connect our server. See, it's saying can't reach. The meaning also they can't reach. Why? Because I changed the security group. Now only load balancer is allowed to access. So that means how to connect then? Then how the a individual can connect? How a person can connect to the instances then? Then load balancers given as a link URL, right? What is DNS URL, right? Where you can find it? Go to details, come down here, you copy this link. You copy this link, and now these are all failed. Now close all of them, and click on, and now click on this link, enter. Now our load balancer connected to server 3. That means, assume like this, we got a request from internet. Now it found our one of the server which is having cyan color 3 is free, so it is connected to server 3. Now another person this time connected to from another browser, same copy, use the same link and entered. Okay, it again connected to the same link, right? Okay, no problem. Click again, click enter again. Now this time it connected to server 1. Again refresh. It's connected to another server now. The same link, no change in the link. That means the load balancer is switching to different servers. So what we tried today to understand, we tried that our load balancer, how it works, how it can switch to different instances whenever it is busy. So this way a load balancer can be used. Any questions till now? Any questions till now? You also can try. You use this link. Now try to open this link on your browser. You try to open this link. I pasted to you. Anybody can use it from anywhere in the world. You try that and let me know what you are getting. I pasted the link.
Yeah, we are getting green.
And refresh it again.
Orange.
Right. So that means our load balancer is working fine. Our load balancer is working fine. Hope you understand the concept. Let me know if you did not understood. I will, if you not understood, no problem. You listen the video recording, practice it. If still not able to understand, on Monday I will repeat the session if required. On Monday I will repeat the session if required. If any of you required, okay. As of now, what I will do, I will. What we have to do, we have to clean them. I hope you know you will take care. You have to clean them. You have to remove all the whatever you created. Everything we have to remove one by one. So go to your load balancer. First of all, terminate your instances. Don't be careless. Okay, remove after practicing. Remove everything. Okay, one by one you remove each of them. Okay, whatever you created, remove everything. Okay, that's all for today. Tomorrow we will attend for session 2 for Linux. Okay, right then. Thank you for your time. Have a good day. Take care. Triveni, Shibin, can you rejoin please?